So you might have noticed this little what is it, XKCD comic that I have on the top of the page, and it talks about how the person used to think that correlation implied causation. In other words, if there's a correlation between uh, two variables, that must mean one causes the other. And then, of course, I'm hoping that after going through the textbook and maybe some of the other work, that you realize that isn't the case. Certainly, this person, the cartoon is trying to make that point. And what I want to do is give you an opportunity to show that you do understand that point, and then to be able to understand what can happen between that gets in the way of talking about correlation between two variables. So I have made this. I've made this assignment for you as if you want to do the discussion forum post about it, and it sends you out to the Spurious Correlation website. And this person has developed all kinds of crazy variables and see how they're correlated. And this bachelor degrees awarded to physical science and science technologies and the distance between the sun and the moon. Um, very strong correlation, almost a perfect positive correlation. You see the p-value is less than one, so that means the difference. So this, when you're doing a significance test with correlation, you're trying to show that it's different from zero. Because if there's zero correlation, right, you don't see any kind of pattern. So, and of course, there's nonsense. There's something else happening here. It might be just time or whatever. So what I did, and then so it's a solar. Let's see. They tried to correlate degrees awarded in journalism versus solar power in Malta. And here's the scatter plot. Again, that's a very strong correlation. I don't know. I don't know if there's probably any relationship there. So, but anyways, you've seen enough. So what I want you to do is to return out here to Spurious Correlation and click on here. Let me get a pointer going so you can see it rather than just my mouse. You're going to click on Discover. And then suppose I feel like talking about stocks, and then I see Amazon stocks price. So I'm going to click on that. And then he says, okay, with that, with the Amazon stock price, the Amazon stock price correlates pretty highly with these variables. And it should they tell you the correlation here. In the first perfect correlation with first name Stevie. I don't even want to go there. The one I found that I wanted to talk about is U.S. household spending on beef. Where is that? No, not on my major reply. Here we go. This is the one I create an example for. And here's the relationship. It says there's a correlation of 0.84, which is pretty strong. And then now this is not a scatter plot. This is just some time plots of both variables of household spending of beef and Amazon stock price. Which we want to look at is the scatter plot. And see how I keep scrolling down. So there's the scatter plot that plots Amazon stock price is X and household spending on beef and Y. Um, I might have done this. No, this is how I did it. Okay, so what you would do is if you wanted to use this, actually I used it, so you can't, but screen capture this, and then make sure you get the measure of the correlation, and then what you're going to do is you're going to do this. And I have this linked. Let's see. This was my example that I made a bit ago about this. So there's that scatter plot. Uh, Amazon is my explanatory variable. Amazon stock price is my explanatory variable, and household spending on beef is my response variable. And then, of course, there's it's a high correlation, but there's no way that stock price of Amazon stock price has any causal effect on the price of beef. So there must be some third variable, some lurking variable that's causing that high correlation. So I actually did come up with this. I didn't use AI to give me an idea. If the two things you pick, you don't have any idea, go ask AI, see what it gives you. It'd be more interesting if you don't, but certainly, it's. just make it your own. So I said, well, let's see. Economic forces on beef, such as, well, let's see. They were they were killing cows not too long ago because of drought, because of food, because of low beef prices. And then what happened then as a result, and that's what's happening right now. I'm recording this in fall 2025. Um, price of beef is skyrocketing, and those economic forces are what's causing the price of beef to go up. It doesn't have any effect on the Amazon stock price. So this is called the confounding lurking variable because it's increasing the correlation, but it's not having any effect. It confounds the relationship, and it only has so when you draw these circles that are trying to draw the diagram, which I want you to do. You want to do one for confounding, one for common response. The confounding will just look like this. It could affect just Y or it could affect X. If it affects both, that's going to be a common response. So then the lurking variable I came up with for doing the common response is, well, if people are getting paid more and more in their jobs, they'll have more disposable income to invest. And because if they're buying Amazon stock prices or Amazon stock and more people are doing that, the price will go up. I mean, that's the goal, right? And then also and so that's how the higher paying jobs could be affecting the stock price. And then with people will have higher paying jobs, they have more money, which they can buy more expensive meat like beef. And that would also increase what people spend on beef because they have more money to spend on it. So the common response, see how it's affecting both of them. Eh, And that is strengthening that correlation of 0.88. Okay, and you don't have to really, I mean, if you write enough in here, you don't have to write anything else. You're explaining what the correlation's with doing. And so I'll reiterate here, confounding it affects just one of the lurking variable affects one of the variables. Common response to lurking variable affects both of the two measured variables. Okay, and that's one way we can get high correlation that doesn't cause there's no causal relationship before that between them. Okay, so I'd encourage you to try this for a post this week, and I'm hoping I want to see what you do. It'd be great. Maybe I should go back to the site and make sure you know how to pick some things. So here, let me come back to um, is it just this site? Yeah, Spurious Correlations. And what you're going to do is you're going to come back to that site where they talked about discover your own. This is about him. Let's see. Here we go. Came up for me. Click discover, and then pick some variable, and they list these few, but you can see all internet memes and pick something there that interests you, and then red pill, blue pill, and then he lists all these other things that are correlated highly, and you could pick I don't know whatever average milk price and looks like that's a very well. That's not remember that's not the scatter plot. Correlation is 0.962. Notice they're supplying R squared also the percent of variation. And there's a scatter plot, and you can go decide on what you wanted to for a lurking. Think up a lurking variable. A lot of times, what I had my Oxbow students do this year, and a lot of times what came up with them, what the AI suggested was just passage of time. If that's all there is, okay, but it'd be more interesting if you find something else. Okay, so hopefully that helps you out. And if you have any questions about it, give a yell.